With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, our question is which is the correct statement? So in the question given, among these statements we have to choose the correct statement. So first statement is in simple cubic close pack arrangement that no octahedral void is present at the edge center. So in simple cubic close pack arrangement, that is SCC, the atoms are only present at the corners of the unit cell. So when the atoms are only present at the corners of the unit cell, they contribute like one corner atom contribute 1/8 to one unit cell, and 8 corner atoms are present, so that will give 1. It means the number of effective atoms per unit cell in simple cubic close pack arrangement is 1. And it is said in the statement that no octahedral void is present at the edge center. So yes, this is true, because atoms are only present at the corners of the unit cell. No octahedral or tetrahedral void is present. So this is true statement. Second one is in FCC unit cell, octahedral void and tetrahedral voids are vacant. So if we talk about FCC unit cell, that is face centered cubic. So in face centered cubic unit cell, the atoms are present at corners as well as at each face center. So in FCC arrangement, atoms are present at corners as well as each face center, and the octahedral voids, these are formed by the, when 6 atoms they are arranged in the form of octahedral, so they will find the octahedral, they will form the octahedral voids, and tetrahedral void, it is formed by the 4 atoms which are arranged in a tetrahedron form like this. When one atom is here present, so this, it is formed a tetrahedral void. And the octahedral void is found by the, when 6 atoms so one atom is lying above is these 4 atoms and one is lying below, so it can be represented in this 2D plane as this. So they arrange in the form of octahedron. That means this void or space that is created is known as octahedral void. So tetrahedral and octahedral voids are present in face centered, but they are vacant because atoms are only present at corners and at face centers. So the tetrahedral and octahedral voids are vacant. So this is also correct statement. Third is packing fraction is simple cubic unit cell greater than BCC than FCC. It means it is given that the packing fraction of FCC unit cell is greatest, then BCC, and then comes the simple cubic cell. So we can see this as in simple cubic unit cell, only atoms are present at the corners, and the corner atoms, these are 8 corners, and one corner atom contributes 1/8 to one unit cell, because the corner atom is shared by 8 unit cells. So this will contribute 1 it means its number of effective atoms, that is Z, number of effective atoms per unit cell, this is less because it is 1. So its packing fraction is less, and it is only packing fraction in simple cubic unit cell is only 52.4%. Then in BCC, that is body centered cubic, the atoms are present at the corners and one atom is present at the body center. So corner atoms contribute 1/8 and one atom present at the body center. So this will give us Z is equals to 2. It means here the effective number of atoms per unit cell are greater than the simple cubic. So the packing efficiency will also be greater, and that packing efficiency is 68%. And then in FCC, that is face centered cubic unit cell, the atoms are present at corners as well as each face center. So corner atom contributes 8 into 1/8, and the face centered atoms, that are 6, because there are 6 faces in a cube, and face centered, one face centered atom contribute 1/2 to one unit cell, because that face centered atom is shared by 2 unit cells. So this will give us 1 plus 3, that is 4. It means it is having highest number of effective number of atoms. So the percent occupation or the packing fraction will also be higher, that is 74%. It means the packing fraction is highest in the FCC unit cell, then in the BCC, and then in the SCC. So this is the true. So this is also correct option. Last one is size of void is cubic, then octahedral, and then tetrahedral void. So size of void, this can be so this is apparent from the radius ratios. Because it is the ratio of the radius of the atom which can exactly fit into that void. Radius ratio is, it is the ratio of radius of the atom or ion which can exactly fit into that void So radius ratio rules, which says that the ratio of the cation to the ratio of anion, it is when in the range of 0.225 to 0.414, then the tetrahedral voids will be occupied. And when this radius ratio becomes more than 0.414 to 0.732, then the octahedral voids will be occupied. And when this ratio becomes more, that is 0.732 to 1, then the cubical void will be occupied. It means the cubical void will have the greatest ratio, radius ratio, because the atom which will fit into the cubical void will have the higher radius ratio that can exactly fit into the void. It means the cubical void is greatest in size. Then comes the octahedral void and then the tetrahedral void. This can be confirmed from the radius ratios. So that is also true. That is cubical void is largest in size, then octahedral, and then comes the tetrahedral. It means all these statements that are given, they are correct. So the options are A, B, C and D. All are the correct statements. So I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.